Alright, so solving a system of three equations with three variables. The first thing that we need to do is reduce it down to a system of two equations with two variables. So I need to combine the equations to where one of the variables is going to be eliminated, to go away. And there could be an easier way to do this, just whatever kind of pops out at you. But the first thing you need to do is decide what variable do I want to go away. Do I want to work with x and z and get rid of y, or do I want to work with x and y and get rid of z? Do I want to work with y and z and get rid of x? Honestly, doesn't matter. You just have to make that decision and work towards it, okay? I'm going to make the decision that I'm going to get rid of the x's. So I need to combine two sets together to where my x's are going to cancel out. So I'm going to combine the first two equations together and cancel x, and then I'm going to combine the first and the last together, and again, cancel x. So working with the first two equations, if I want my x's to cancel out, I'm going to do this by elimination. So I have a positive 2x in the first equation. I need a negative 2x in the second equation. So I'm going to multiply everything in the second equation by negative 2. And that'll give me negative 2x plus 4y plus 6z equals negative 4. And I'm going to combine that with the first equation. So 2x plus 4y plus z equals 1. So adding those together, my x's cancel out, and I get 8y plus 7z equals negative 3. So now I have one equation with just two variables. Now I need to get another one. Get another equation with two variables. So that's where working with the first and the third equation comes in. And so again, I need my x's to cancel out so that I have the same variables to work with. So I need to multiply. I have a positive 2x here. I need a negative 2x for it to cancel out. So I'm going to multiply again this bottom equation by negative 2. And that gives me negative 2x minus 2y plus 2z equals 2. And adding that to my first equation, so my x's cancel out, and I'm left with 2y plus 3z equals 3. All right, so now I have a system of two equations in two variables to solve either by substitution or elimination, what we looked at last week. So now I can work with these. Again, I'm partial to elimination. So looking at, I have 8y and 2y, 7z and 3z. Which one appears using elimination to be easier to cancel something out? Possibly the y's, right? This is an 8. I could just multiply by negative 4, get negative 8, and make that y cancel out, right? If you wanted to go with the z's, that's fine. You'll get the same answer. You just might have to do a couple more steps. But so I'm going to go ahead and cancel out the y's using elimination. This is a positive 8. To cancel it out, I need a negative 8. So I need to multiply this equation by negative 4. That's going to give me negative 8y minus 12z equals negative 12. So adding these together, 8y minus negative 8y cancels out. 7z plus negative 12z gives me negative 5z. And negative 3 plus negative 12 gives me negative 15. So dividing by negative 5, I get z is equal to 3. That is a 3. All right, so now I have my first variable solved. So from here, it's just plugging back in, working my way backwards to find the other two variables. So I know what z is. So going back, I have equations with just y and z. So if I plug in z, that'll tell me what y is. It doesn't matter which equation I plug into, I just need to pick one. So I'm going to pick this one right here. Just because it has smaller numbers, you can use the other equation and get the same exact value. So I'm going to plug in 3 for z. So I get 2y, scoot that up, 2y plus 3 times 3 equals 3. Just plugging in z. So I get 2y plus 9 equals 3. So 2y equals negative 6, subtracting 9 from both sides. So y is equal to negative 3. So now I have two variables solved. I know z is 3, and I know y is negative 3. So now I can do back substitution one more time and go back up to one of my original equations that has all three variables in it. I can plug in what y is, plug in what z is, and figure out what x is. It does not matter which equation we choose. You'll get the same value either way. So I'm going to pick the one with the easiest numbers. To me, that seems like it would be the last equation. So I'm going to take this last equation, the x plus y minus z equals 1, and I'm going to plug in the values we got for y and z. So I'll have x, do it again, x plus y was negative 3, if I'm not mistaken, minus, we found z to be 3, equals negative 1. So I have x, positive and a negative just make negative, so negative 3 minus 3 gives me negative 6. Add 6 to both sides, and I get x is equal to 5. Right? So our final solution, if we want to write it as a coordinate, is 5, negative 3, positive 3. That's my x, that's my y, and that's my z. Okay. Now, the variables that you solve for, the order that you do things may change, but the process is still the same. Very first thing, if I'm dealing with three equations and three variables, I need to combine them, two sets, combine them so that I get just two equations with two variables. Then solve down, substitution or elimination, and figure out what those two variables are and plug it back in to find the third variable. All right, just that one extra step from solving one system with two equations and two variables.